This video details how to use the OceanAlpha USB base station software. The software is a third-party app employed to control the OceanAlpha SLV20 USV, basically used for autonomous data capture, manual USV control, boundary and route planning, data import and export. Now, for the purpose of this video, we are going to show you how to use this exclusively to do this. The USB base station software is a very powerful software that provides full control of the USV. It's responsible for mission planning, mission status, communication setup, navigation setup, and video monitoring. Now, to create a new mission, there are several buttons that aid in the planning project. Now, we have the Open Mission tab that is responsible for opening previous missions that have been saved in the software. There's also the Save Mission that is responsible for saving a mission that has been planned for next time use. There's an Import Mission button that is responsible for importing mission files. And there's the Grid Line, which is also responsible. It's used to create navigation lines by setting the number of rows, columns, and spacing of lines. Likewise, lines to be generated automatically. Then we go on to the parallel lines, which is the fifth tab. That is for setting lines on the left or on the right side of the selected lines, parallel to the line that has been drawn. This is usually generated automatically. Then we have the Draw Boundary tab. It helps to create survey lines or waypoints within a specific area. Then we can go on to the sampling setting. That sets sampling waypoints, sampling volume, and water sampling monitoring. That's exclusively for water sampling, and that you require a water sample payload. Then we go on to the monitoring setting. It is used to set monitoring waypoints and monitor lines in water quality monitoring mode as well. Then we go on to the edit waypoints. It provides interface to edit waypoints like coordinates, delete and switch waypoints. Then there's the clear waypoints tab, which is used to clear waypoints or the boundary. And finally, there is the send mission tab, which after creating your boundary and planning your routes is used to send a command to the OceanAlpha to be able to map your waypoints, or in this case your route, automatically. It can only be used in the auto mode. Then we go to the map ranging tab. This tab is used specifically to measure the distances between any 2 points on the map. So when you need to measure a distance between those 2 points, you left click on the map and you move the mouse. As you drag the mouse along, you're able to get the distance between those 2 points. The next tab notable of mention is the manual control tab. It's also found on the menu tab. When this is activated, we're able to control the USV manually by checking the enabled keyboard control. On the on-screen, up, down, left and right can be controlled manually by the left click when this is activated. Right click on screen to exit the manual control. When done, the OceanAlpha has selected maps from which you can download from. That's the Google Maps, the Bing Maps, that's the Hybrid Maps, etc. etc. Now to download a map, you left click to select an area of interest where you want to download. In the event the area isn't captured clearly on the map, after the area has been selected, you click the download button to download that area of interest that you have chosen. Based on this, you can use it to plan your work. Screen and center display is responsible for the full screen display of the software interface, whereas the center display is to locate the USV quickly in the event the USV is off the screen of the OceanAlpha software. The auto homing button helps to move the home position of the boat if it has been wrongly placed to the correct position needed for the survey to be able to be undertaken. When a base station is connected with a USV or multiple USVs, the connected USV information can be displayed on the right of the screen. Choose a USV to send a mission to and control the navigation accordingly. What the system monitoring does is very vital in the OceanAlpha software. It's responsible to display the data transmission and receiving, the status of the communication ports such as the main controller, the SM32 controller, the navigation box, and this information actually helps the technical engineers to be able to diagnose problems that arises in the communication and capture of data accordingly. The function of the video monitor tab is to make sure all the video captured by the USV is in sync. There's an option to take images or pictures from the videos. There's also an option to record what is being captured by the USV as and when the work is being done. And there's an option to return to home when video is being captured. There's also an option to orient what the video is being captured as and when the stream is being broadcasted. There's an initial settings provided for the USV which is able to set the various cameras for video capture. The video channel has 4 main channels which can be cycled through as and when needed. With the mission status button, the operators can check the current status of information of the USV, including the positioning, the speed, the line, the tracking offsets, and the mission progress information. You're able to even check the speed of the current work that is being undertaken, the distance as well, the azimuth, and any other functionality of the USV. To set the navigation and mission information of USV, the setting parameters can be changed anytime in the navigation or status. The parameters include the navigation parameters, the speed parameters, and the speed settings, which there's no need to change the default setting. You can have a minimum of 0 and a maximum speed of 1. The follow mode is specifically designed to set a USV to accompany or follow the mother vessel during navigation. Before the follow mode navigation, it needs a strong GPS connection for the mother vessel to set the distance and the relative position between the USV and the mother vessel. Likewise, the azimuth can be set at preferred navigation bearings for the USV to follow. The device control switches control between the power, the navigation light, and the backup switch. The ENC mode is also a very useful display mode. It's a display chart mode which is able to toggle between the satellite mode and the terrain mode. When you switch to the default view, it makes the map quite light to be able to handle during data capture and sounding. It helps you to be able to hide land and several display formats available, which makes the works quite easy to preview as you can see here. So when you are done, you turn the display chart off, then you toggle back to the satellite mode. The parameter settings has a lot of features which include the collision avoidance function, which helps you to be able to toggle it on and off. The auto homing feature that helps you to be able to reposition your home point in the event the USV is off its mark. It helps you to be able to enable to show trajectory in the parameter settings, which can help you to generate the USV moving trajectory on the map. It has a 4G communicating function which uses between the 4G connection for the setting, and as usual, a default to the USV, which is a network bridge connection. Now, as mentioned earlier, the software sits on a base map. There are quite a number of base maps which we can use. You have the Google map, the Bing map, and several from which you can choose from the drop down from the screen. Now, in the event for which your work is done, you can put it on standby, or you clear trajectory to clear old or previous work. In the event the map is not enough, you can zoom in or zoom out, which will cause a little pixelation depending on the speed of your internet. So from the new mission tab, you can create waypoints by clicking on any portion of the screen. That's by left clicking to create those waypoints, and you can right click to delete them as well, or use the clear waypoint button to remove all waypoints created. From there, you can continue to draw a boundary by clicking on the draw boundary tab, left clicking on the screen to create the boundary. You can click on the vertices to move them around or change the boundary as you wish accordingly, and then clear your waypoint as and when needed. Now we go on to the power line tab. It's used for creating routes for planning missions, where you select the line spacing, select the power line, and define the number of lines you need for your left and on the right side of the power line created. This is a fast way of defining routes, and when this is done efficiently, click the clear waypoint button when done with your editing. The grid line button is also a useful way of creating routes for your autonomous planning. Select your spacing, you define your number of columns and number of rows, then you generate your grid. You can subsequently generate the path for which the USV is supposed to follow. When done with the generated path, you can clear the clear waypoint button to move the route created. Now, there's another way to create your route within a defined boundary. So we go about this by creating power lines at designated line spacing. We define the left and the right lines to be created from the power line generated. When the routes are created, we go ahead to draw our boundary for which we want our route to be surveyed within. So we left click on the screen from the boundary creating tool. We go around till we generate the last point by left clicking on the boundary, and then we apply the boundary, which automatically deletes all extra routes created and limits the drawings to the boundary that we created, which will be required for our survey. Now, there's another tool worthy of mention that is known as the Geofence tool. Now, what this tool does is it helps in the autonomous data capture of the USV. When an area is geofenced by either digitizing or extraction from a map, you should normally select the area of interest to be geofenced, and then you apply the settings, and this in turn highlights that area so that in the event of a data capture, the USV is able to go around or completely avoid the area that has been geofenced from the mission data capture. From the video, you see it is highlighted red, so that when you plot your mission in the autonomous mode, it will go completely over or around it because it has been geofenced. This is very critical in mapping areas that are marshy or that has tree stumps or that has so many obstacles in such water bodies, tailings, or area of interest. So you can see from here, the USV is undertaking the autonomous mission, but immediately it gets to the geo-zoned area or geofenced area, it goes around it. It is very critical for planning. Now, with all that has been tackled so far, we're going to plan an autonomous mission using the OceanAlpha BaseStation software. So we click our power line, and then we select the number of lines we want to use on both the left and the right side of our power line to create the routes created. When this is done, we click our send mission button to initiate the autonomous data capture. When this is done, realize the USV moves to the beginning of the line to start mapping of the route automatically. This is done entirely by the autonomous navigation system on board. We're able to also switch the view from the satellite to the default view and then back to the satellite view when there's no need for it. The data continues to capture as long as it is in the auto mode. There's also an option to view the videos whilst the data is being captured to be able to have a feel of the nature or the color of the water being mapped at the moment. The USV follows the route through and through to the very end of the line. You're able to switch the video from the stack view to the preview view mode so that you have a feel of what the data is being captured. When the work is done, the USV is automatically returns to its home point after hitting the auto homing button. You realize it moves directly to the home point that has been set when the data capture is done, which is later stored on the laptop to be used later for processing.